Thank you for joining us here today. We're here for DA302, Protecting Sensitive Data in Huge Datasets. My name is Scott Ellis. I'm a product manager on our cloud security and privacy team. And a few of us are going to be presenting today. But before we start, what we're going to be talking about today is sensitive data and how to protect it. What you see up here is just some examples of what that might look like. We're just showing someone typing in some random sensitive data. And what we're going to cover today is, again, when you want to do something with this data, maybe you're sharing it with teams, maybe you're running analytics, training an ML model. How do you identify sensitive data? How do you redact and mask it, kind of protect it inside the data itself? And then how do you measure that risk of sensitive data or identifiable data? So to get started, I'm going to welcome Felipe here, and he's going to take you through some of it. There you go.
Thank you, Scott. Hey, hi, I'm Felipe Hoffa, Google Cloud Developer Advocate. Super happy to be working with the product manager for DLP and my teammates that will show you the demo soon enough. So let's talk a little bit about how do we find the balance between data utility and risk. And let's see in some public data sets how useful they can be. So for example, if you want to go from one place, from A to B, this is a screenshot that I took the night before I had to give a talk in Berlin. And I could see that it would take 20 minutes for me to get from A to B. But turns out that the next day, at peak time, when I needed to get there, instead of 20 minutes, it took me 30 minutes to get there. And it's super interesting. I'm glad that we can get these kind of predictions with Google Maps. But the question is, how can we get similar predictions by ourselves? In some places, we have public data sets, like in New York. I made this chart by plotting every taxi trip that people have taken during a year around New York. That's like 170 million taxi trips per year. And each of these dots, it's one pickup point. So you can use this data. You can start with a query like this. And you can look at the average to get from any place to any place at any time of the day, during any weekday. And you can run your own predictions. And that's really useful. Then I did a chart like this where you can see hour by hour how the city moves in a different way. People are taking short trips, long trips. In the morning, everyone is taking, starts at Central Station and they spread out around the city. And I'm really, really happy that the city has published this data. Then you can use this for public policy. For example, you can see here this chart that at 5 p.m. in the blue line, there is a big dip on the number of taxi trips that people are taking per hour. And the question is, why do we have that dip at 5 p.m.? It's not because people want to take less trips, but this is because there is a policy in New York that no taxi driver can be driving more than 12 hours in a row. So the city enforces that law, and then all the taxi drivers decided to do their shift change at 5 p.m. So everyone goes back to their garages, and the city doesn't have taxis. And you may want to compare what's the behavior with Uber or other for hire vehicles that don't have that regulation. Well, as you can see in the red line, they don't have that dip. And the question is, how do we use this public data to find better incentives so we don't have a problem and people can find taxis at that time? If this is 2015, if you go to 2016, you can see that Uber and the other for-hire vehicles caught up to what the taxis are doing at the same time. In fact, at 5 p.m., you have this dip, but you don't have a dip for Uber. And then in 2017, you can see how they have surpassed. They do way more trips than the regular yellow cabs, and the taxi drivers still have that gap at 5 p.m. And this is on the side of how we can drive utility out of public data. On the other side, on the other hand, we started seeing this kind of news, like, whoa, there is a privacy risk on publishing these logs. We can find out where people are going, where celebrities went. And the question here is, how do we find a balance between not publishing this data, that would be the best way to preserve privacy, and all the utility that we can get as individuals or we can get at the city level from publishing this data. And to find this balance, to reduce risk when publishing data, Scott is going to tell us some of these techniques.
Thank you, Felipe. Great, and so so Google has been working with a lot of different applications with a lot of users for a long time, and so because of that, we have done a lot on the security and privacy side to understand our data and to protect it so that we can still make it usable for valuable services for our customers. And so we're going to share some of the tools and techniques that we've released for you to use as well to do this. One of those tools is our Cloud Data Loss Prevention Infrastructure, or what we refer to as DLP. And this covers three main things that it will do that we're going to cover today. Is it helps you discover and classify sensitive data. It helps you go in and mask that data. Let's say once you find it, it helps you kind of redact it, reduce it, mask it, tokenize it, things like that. And this third thing is it helps you measure statistical risk that's still in the data or potentially still in the data so you can understand what's there. And we're going to cover those today. I'm just going to give a quick overview. And just to get started, we think a lot about security, privacy, and compliance. All this infrastructure has gone through a lot of audits to make sure that as we're handling your data, you can check some of these. We actually have a security page dedicated to compliance as well. And you'll see our product listed there as well as many others. But let's get into what it does. So the first main capability that it helps us with is discovery and classification of sensitive data. So this is things like personally identifiable information, PII, different types of identifiers. And a lot of what we're going to talk about today is how data, when it's tied to a human individual, can be sensitive. So right, you release some number, it's not that sensitive, you tie it to an individual's phone number or email address, all of a sudden that number is very sensitive because I know who it's about. So to get started, when you think of direct identifiers, things like PII, first thing is discover it, find it in your data. Out of the box, we have about 90 different types that we support that you can simply go in, turn on, and look for, both in the US, global, and several other countries where we have unique identifiers in that country. Next is, what do you do when you find it? So there's a lot of techniques. We're going to cover a few of them here, but you see in this animation, we're showing a structured data table. And there's 4 columns, and I'll kind of talk through what we're doing in each column, just as an example. So in that first column, it's an identifier. And we don't want to expose that raw identifier, so we are using a format-preserving encryption method to create what we call a deterministic token. So what's happening is we're actually taking out the value and replacing it with something else that still retains the referential integrity and the statistical properties of that data. That's key because if you want to join on that data, you want to run analytics, you want to do a group by, an average, you still can do it, but you're just not revealing that raw PII. In the second column, we are taking some, somewhat distinguishing data and we're making it less distinguishing. A term referred to as generalization or bucketing. And the idea here, again, is we're going to take something like a senior engineer or vice president, and we're just going to bucket them into a general bucket called engineer. In the third one, we're doing just partial masking. It's pretty straightforward. In that fourth column, we're combining our inspection with our masking. So we're actually hunting through the unstructured data in that column, finding the element that's sensitive, and then doing something there. So in this case, we've redacted a few things or applied that partial masking again. And again, all of this running is sort of one operation. So the next part, when we talked about risk analysis or re-identification risk, I'm going to cover it a little bit, and then Felipe is going to go in more depth. But just to give a high level, let's say you removed all the PII out of your data, all the direct identifiers, all the things that you can think about maybe seem kind of obvious, so if someone's credit card number, social security number, you've masked it or you've done something there. But what about something like job title? We kind of hinted at it in the last slide. But even just looking at these 5 rows of data, you'll see that there's 4 software engineers and 1 CEO of Google. So that metric that I have next to it, let's say it's a very sensitive metric. Maybe it's the rating that they have or a donation that they made or some financial or medical information. If you were to release this information, anyone who sees this is probably going to figure out who the CEO of Google is. It might be one person. If you look historically, it could be 2 or 3 people. But the idea is it's a single individual or a small group of people are going to map to that value. And everyone kind of knows who it is. Whereas if I said software engineer and I did an average of those 4 values even, you probably don't know what I'm talking about or who I'm talking about. You're just getting a nice usable metric, which is the average for the software engineer. So when we talk about re-identification risk analysis, this helps us identify and pull out some of those high-risk outliers. And let's just give a couple examples. Again, this is kind of what the bucketing thing looked like that we did. We went in and took something more distinguishing and bucketed it to be less distinguishing. That's one way we would solve that job title. We'd bucket maybe CEO or VP or senior VP or whatever these kind of high-risk outliers are into just one bucket called executive. Another thing we do with dates is kind of unique is an option called date shifting. So in some cases, the actual date of a transaction or the date somebody was admitted into a hospital can be sensitive by itself. But if you were to redact it or blur it just to something like the month or the year, you start to lose some granularity there, and it can be very hard to analyze a sequence of events. So in this just really simple example, we've taken records and we basically generate a random shift in the context of that person. So in this case, it's a medical record number that we're using. The idea is that we're now going to shift all the dates for that one patient consistently, but then pick a new random number when we get to the next patient. So we're going to lose some data there. We're going to lose when the dates are the same between 2 patients, but we're going to keep that sequence of events within a single patient, so you can still do things like duration, and kind of predictive based on dates, but you're not going to reveal that raw date. We talked about some of the built-in detection. Here, we also allow you to go in and augment that detection. This is just a very simple example here. We're showing a little bit of the code of what a custom detector might look like. We talked about sort of tokenization, and I want to show kind of what that looks like. You're really using cryptography to create these deterministic tokens. In this example, we're just showing the raw key that would be used, and every time we have that key sent into the API or sent into one of the processes, you're going to get the same output for the same input value. So in this case, as you see the first 2 rows, they generate a token that is the same. And similar, if you use a method that can be reversed, you can reverse those tokens as well. And so when we apply this to that original animation that we saw, what we see down below, and we're just kind of applying different techniques based on different types, is you can start to protect this data, even in the case of unstructured data, or you might want to go in and take that information, train something on it, or even share it so people can see what's happening in a support case. But by reading that bottom one, you can't obviously pull out and identify the person like you could in the top. But you'll notice with the credit card number, even in free text, we've tokenized it in a way, added some metadata that we can actually reverse that if we needed to, if we had authority to the key. And so these are some of the techniques that you can apply, especially looking at a lot of the ones you would do on these kind of direct identifiers. But how do you know when to stop? How do you know when it's enough? Especially if you're going into a case where you might be sharing this with a partner or exposing it a little bit more broadly. What else do we need to worry about? And for that, I'm going to pass it back to Felipe, and he's going to go in a little more depth.
Thank you, Scott. Okay, so what do we do next? We know now how to take our private data, how to take our identifiers. We can mask them, we can do different things with them, we can bucketize it. But the question is, how do we measure that we did enough? How do we decide this is the place where we stop? So to understand the re-identification risk, there are 3 basic concepts. One is the identifiers, things that we really want to remove before publishing data or sharing it, a name, a credit card, a government ID. But we also have quasi-identifiers, my age, where I live, and things like that, that maybe if we only keep my age and my place of birth, maybe I will be completely anonymous in a data set, or maybe someone will see that we have someone from Chile that's a speaker at Google. They will be able to identify me regardless of that. Those are my quasi-identifiers. And we also have sensitive data that is what we want to protect. My health condition, salary, something that I would not like to reveal, that might be revealed if we go through the quasi-identifiers. So there are different measures of how you measure how risky a data set is for re-identification. There's k-anonymity, L-diversity, k-map, delta presence. I will go through 2 of these now. The good thing is that the DLP API can measure all of these can give you a value for all of these. So let me show you k-anonymity, which is a property of a data set that indicates the identifiability of its records. And you want to measure how many individuals you have in any given group of data. K equals 1 would mean that there's only one person in each group, so in certain groups, and that would make them pretty identifiable. To show you an example on a public data set, I'm going to take all of the births in Mexico that Mexico has published, and I took all of them between 2008 and 2013. We have about 13 million babies that were born in that time. Mexico publishes a lot of data about the babies and about the mothers, including things like where the baby was born, what was the gender of the baby, what was the education of the mother, and what's the civil status of the mother. What can we do with this? This is a query that I'm running in BigQuery, where I'm grouping them by all of the babies by these 4 variables. And you can see some groups, like the first one there is that we have 405 groups that map to only one person. That would be k-anonymity equals 1 for this data set, because we can find some individuals. The bigger groups from the largest places don't have this risk, but there are some groups that are really, really narrow. And then we need to decide, do we want to publish a data set that has a k-anonymity of 1? Do we want to broaden these groups or do we want to remove all of them? But at least we know that there is a k-anonymity equals 1. And then there are different ways of measuring it. I did this with a SQL query, but we also bring it in the DLP API, so you can use the API to just run a call like this, and instead of wondering how to calculate these values, you can just call DLP, ask it to, in this case, we are asking it to calculate the k-anonymity, and we're giving it the columns, the quasi-identifiers that we want to use to measure this value. And then you get these values straight from the API. Now, k-anonymity is a pretty standard value that a lot of the industry, research, science uses before sharing data sets, but it's not enough. Usually they say, oh, you can publish a data set once you have k-anonymity equals 5. But well, I skipped this slide on how do we fix this if we want to improve k-anonymity. You can use generalization, so instead of publishing, you could either remove some of these rows, or you could generalize. So, for example, saying the specific age or birth date of someone, you could have larger groups of people between 20 and 30 years or so. But let me look at this example where if I have a k-anonymity of 5, and I have a group of 5 births from postgraduate divorcees in Coahuila de Zaragoza. This is something that I could know very easily out of someone. I could ask them, I could know when they were born. I could ask them, hey, where were you born? Was your mother, what was the education of your mother? What was her civil status? And turns out in this data set, I can find 5 women that had babies around this time. And we could say that they are pretty safe for identifiability. And even if I cannot tell who each one is, they all have something in common. In fact, this data set has a lot of sensitive data, like the health status of the mothers at the time. And all of these 5 mothers have hepatitis B. And maybe they didn't want me to know that, But even though we have Anonymity 5 here, we are still missing diversity. We would like to have more diversity of the status. So if we had different values for hepatitis B in this group, we would not be able to tell that all of them have it, and we would not be able to tell if an individual has it. And how do we call this measure? We call it L diversity. And again, you can just call the DLP API ask it to measure the L diversity, and you have to give it not only the quasi-identifier columns, you also have to set up what columns do you want to measure for sensitive attributes where you want to have more diversity on the values. And then the DLP API would tell us, oh, L diversity for this data set is 1. You might want to change some of these rows. You might want to delete them. You might want to generalize them, etc. I'm not going to go through all the measures here. K-map and delta presence are also super interesting because they are able to incorporate more statistical data into these measures. But we published a blog post recently, and also our documentation goes over these measures. But to remember here, the best practices when dealing with data privacy, first you want to minimize exposure. With the DLP API, you can remove sensitive data. You can remove identifiers if you want to remove them. But you might also want to preserve some of them to keep the value, but do some tokenization. Do the shifting, do generalization, etc. And to know when you are done, to determine as a group, as a team, as an organization, where to stop, you can measure the risk of re-identification, and you can reduce that risk by taking these steps. But now it's demo time, so let me welcome to the stage my friends Masud and Patrick that will show us how to run this at a big scale.
Thank you, Felipe. Hi everyone, my name's Patrick. I'm with my colleague Masud here, who will be starting up his demo, so he's praying to the demo gods right now that everything will still be working properly. We're part of a team that's called the Swarm Customer Engineering Team. So what we do is that we work with customers who have specific technical problems that they're trying to solve with GCP and try to find a way to solve that problem. What we will be talking about today, what we'll be showing you is linked to, sorry, can you put back the slides? We're not totally ready for the demo yet. I have one more slide, sorry about that. So what we'll be talking to you about today is how we worked with one large financial institution in Canada that had a problem linked to what we just discussed. So they had those big data sets. They needed to de-identify those data sets before they ran analytics in the cloud on it. They actually had pretty strong regulatory requirements to de-identify that data. But they had to do this at scale, and they had to do this as the data was either batched or streaming to the cloud. So the solution that we've built leverages another Google product we've discussed that hasn't been discussed yesterday, that's called Cloud Data Flow, to run that large data set through the DLP API and do those different transformations that we've discussed today. So what we'll do now, we will move to the demo. We will show you how we run those jobs, and then we will explain how that demo worked and show you the result after that. So we can move back to the demo screen. I'll let Masud explain to you how he starts the job, and we'll come back to explain what that job does.
All right. Hello, everyone. My name is Masud Hasan. I'm a customer engineer at Google. I'm based out of Toronto. What I'd like to show you guys today, probably next 10 to 15 minutes, it's how easily you could implement a lot of the concept that Patrick and Scott and Philip just talked about using data flow and DLP APIs. So let's get started. So you can see that I'm actually in my project right now. So what I do is, let's click on data flow. And if you haven't used data flow before, as part of data flow, there are some of the standard templates that you could use. So if I click on create job from the template, and you can see there's a list of already inbuilt template already available to use. So what it does is, it separates your development environment versus execution. In this way, you could just pass some runtime parameter and, just run a lot of those complex ETL tasks. So the one that I'm going to use today is this one here that I'm asking. And let me just start my Cloud Shell as well. So in high level, that pipeline, what it does is it's going to take a lot of CSV files, which I have stored in a GCS bucket. It's going to read from that GCS bucket. It's going to call the DLP APIs. It's going to bulk the request, and then store it in BigQuery. So I'll do a GSUTL here. I'm just trying to find the path where I stored the file. And I know this is where you have it. Okay, so let's just copy this. So you can see that one of the parameters is asking me to give the path for the GCS location. I'll just here .csv. Now for the BigQuery side of things, I already created a data set. Let me just show you. You can see there's a data set called PII dataset underscore, PII underscore dataset, but there's no tables in it yet. So I'll go back to my data flow. So for the DLP project, I'm just going to use the one that I'm currently using. So you also have to pass a template, a DLP template, where actually all the configuration is. So let me just see where I could copy the template from. Okay, so there are a bunch of optional parameters that we could also use. So for our use case, let's just say we're going to use 3000. So this is the parameter that's being used to call DLP APIs in a batch format. So rest of the parameters, I'll just use the default one. But for machine type, let's just use something, a higher machine. Okay, so I think I'm missing a job name. So let's just call it a DLP demo. DLP data flow demo. So you can see just having some of those runtime parameters, I'm executing an ETL job that's going to do a lot of tokenization tasks for me. So let's just run this job. Oh, so you also require the temporary location. So when you're writing it to BigQuery, it requires a temporary location in a GCS bucket. So now this job is starting up. Let me just show you. So you could see there are 4 different files that I have in CSV format. And if I just do a quick count, so what we are about to do, around 1.6 million rows in a CSV, like 4 CSV files, and we're going to tokenize 4 or 5 different fields, which I'm going to walk you guys through in a bit. But it's going to be in BigQuery table format. So with that, I'll hand it over to Patrick, who's going to walk you through the DLP template.
Yes, so let's go back to the slides for a few minutes while the job runs. So what we're doing right now, so the job that Masud started will actually take the data set in batch and run it line by line through the DLP API to do a different number of transformations that were described a bit earlier today in presentation. So basically, we're starting with that data set, these are CSV files, but we would be able to support any type of format. So this is a very versatile, can start from any format to any other. Some of those columns have identifiable information that needs to be de-identified. The problem that we're trying to solve then is try to identify what those columns are and how we configure the LP API to do the right work, so apply the right transform on the right columns. And the LP API has a very useful feature called the MP templates for that. And when we were working with that financial services customer, this is something that was key to the solution, because the problem we're trying, this is all fine and good, this is one demo, we have one data set, it's simple to understand what we do. But as you increase the number of data sets and as you add stream data to the mix, it becomes complex to know what needs to be applied where. The LP templates will allow you to decouple your code that's actually doing the tokenization, let it stay generic, and put all of those transform configurations somewhere else. So what does those templates look like? Those templates are standard JSON files, so can be sent directly as is to the API. I know that putting JSON on screen is not the most sexy thing, but bear with me for a few minutes. We will walk through what that actually means. And those part of the JSON file will identify which columns transforms needs to be applied to. We will have different types of transforms, so two main type of templates, and then different transform. The first one here is what we call an inspect template. The goal here is to run on semi-structured data, well, unstructured data in that case, sorry. So we have some data. In the case of our customer, those were customer service knows fields. So this is a free-form field. People are typing data in there. Customer service people might, by mistake, put some identifiable data in there, put credit card numbers, put addresses, names, SSNs. We've seen all sort of 60 errors in those free-form fields. What an inspect template will do is that it will run through those free-form fields and look for certain type of data that we identified. In that case, we made a list, so we are looking for credit card number, email addresses. There is a series of default info types we can look for. As Scott was saying earlier, there is also some custom detectors that you could put. So that template will actually go and look for that data. So for the column that was linked to this, we will look for data that will mix those info types, either the basic one, the custom ones, or the regex that we have here. So that's the first step. So if we have columns that we don't know if we need to de-identify, that allows us to look for the data. But just looking for the data is obviously not enough. We need to apply that de-identification to the data. So we will do this using the identify template. And in the example that we have here, we will use different types of transforms because we have different types of problems. In some case, you might do bucketing. You are worried about K-anonymity or some other aspect of your data. In some cases, you just want to obfuscate the data or redact it. In some cases, you might also need the data to be re-identifiable. We had some use cases around fraud detection where we want to run fraud detection models on credit card numbers that have been anonymized. We don't want to run on the real credit card number. If we find fraud, we need to be able to get that token back to the actual credit card number. We need to know which customer had fraud. Otherwise, the fraud detection model is useless. So depending on the type of transform that we're using, we'll be able to adapt to those different use cases. In this case, the first example that we have is an example where we can actually go back and re-identify the data. So we will be using, again, we are linking this to the column. The template will say which column in our CSV this applies to. And then, and you have the field user ID here. And then it will apply format preserved encryption to it. Again, no need to go through all of the lines of the JSON. Again, not all that sexy on stage. But what is important to understand here is that we can put this outside of our code base. So this is a template name that's registered with the DLP API. When Masud started his job earlier, knowing the source data set he was running in, he just pointed to that template. The template has all of the configurations. You see the column name, you see the type of transform, you see the keys, the crypto keys that will be used in that case to do the encryption. So you can really decouple that code that's very generic from the actual transform. All of the transform will have similar type of templates. So in this case, we are running format preserving encryption. We might have another case here where we're doing same thing again. We're identifying the column, we're configuring this. In this case, we're doing bucketing on a number. So we talked about bucketing earlier. So we have numbers within the range. We want to replace this with the number at the end of the range in that case. Simple configuration. We're seeing what the minimum value is, what the maximum value is, and now we replace it. So those templates are a very useful configuration element because you do not need, what our customer was scared about was having to write custom pipelines for all of those data sets. And that makes onboarding a new data set very, very complex. You do not want to have to go out and write code every time someone wants to send more data to analytics. You want that process to be as seamless as possible. Using templates and using a generic pipeline in Dataflow, you can do this at scale. You just need to have a team that will decide which columns need to be de-identified. This is normally offloaded to a privacy or security team. Build those templates for new data set, and your data set is onboarded. So very useful to, especially as the number of data sets starts to scale up, and the size of the data set starts to scale up. So at this point, I'll go back to the demo, pass back to Masud. We ran that transform through 1.6 million lines, and we'll see the result of that run.
Let's just see. It just completed, by the way. It took like a few minutes. So first thing, if you guys remember, there are 4 different files. So if you click on one of those transform, you could see that 4 elements added and 4 elements outputted. So you know that 4 files been processed. So if you click on this process file contents, the DLP tokenization transform, you remember we actually used 3,000 batch size. So, for 1.6 million divided by 3,000, you kind of get this number, 536 batches. Then if you click on the process tokenization data, you could see that it's translated to close to 1.6 million. And we just transformed 1.2 gigabyte of data. So the last transform was actually to write to BigQuery table, which is actually matches. So let's go to the BigQuery. So if you remember, in my first set, I actually showed you guys the empty data set. So if I refresh this, you should be able to see the tables being created. Okay, so all 4 tables being created. And I'm just going to get into my data set again. Okay, so if you do a list, you could see those 4 different files being transferred. If you do a quick schema check, so if you just do a head one. So these are kind of our data schema looks like. You could see we actually picked a use case that has a lot of direct and quasi identifiers in the file. So for example, you have job title and age as a quasi identifier, and you also have a direct identifier like SSN, person's name, and credit card numbers, et cetera, et cetera. So if you look at one of the schema, it should actually matches. Okay, let's do a quick count. Okay, so that number matches for all those, the 4 or 5 different tables that we have. And we can confirm that, the number of rows are all same. So let's get into a little bit more in the data. So what if you actually have someone, let's say 18 years old, a CEO for a company? That would be really easy to identify that person. So what we did is I have a query here I could run. And you could see the power of DLP using bucketing. We could actually have, pretty much transform all those records to thousands of records. Okay, so you could see that So first thing you notice the cardholder's name. It's actually completely tokenized. So we are using a crypto hash algorithm to tokenize the person's name. If you scroll right, see all the job titles being executives. And since I'm only querying the age 18, and I'm also using a bucket between 18 and 29 to group them together. So let's just see, query this guy here. Okay, let me do a clear first and then do this. Okay, so let's do a comparison about this record. So this is in the Cloud Shell, you're seeing the actual record. So apparently so Carson, the original name is Carson Winklins, and this person is 27 years old, CEO. So if you look at on the cardholder's name, I'll make it a little bit bigger here. So this is all tokenized with crypto hash. If you look at the job title, so CEO, since we're using bucketing, is being transferred to executive. Look at the SSN number, which is a direct identifier. So if you look, SSN here, 209 number is being transferred. 27 years become 18. If you look at the card PIN, which is also changed, so that's one of the direct identifier that we're using format preservation algorithm. And if you look at the card number here, so it starts with, the original card number says 3735, but it's being changed to a completely different number. Okay? So just quickly, before I end this demo, I just wanted to mention that for the data flow job, it doesn't have to be from CSV, from GCS to BigQuery. It could very easily modify them. The code behind what I ran is actually open sourced. So you could go to the Google Cloud Platform GitHub page and just search for DLP. You should be able to see. Another thing is you could also run those data flow jobs using gcloud comment. It doesn't have to be UI if you want to schedule it with the Cloud Composer or something else. With that, I will hand it over to Scott for the closing remarks.
Yep, I'll take one few seconds before Scott. So as Masud just said, this is all open source. The goal of those is to give you the building blocks to be able to add DLP as part of your ingestion process. So we showed a UI-based demo today. You can start this. You can really use this as building block, create your ingestion pipeline, or add it to your ingestion pipeline that you already have. So as you go, adding more of those ingestion pipelines, you can use this, add the identification. That really enables you to bring more data into the analytics product without having to worry how you will add this or without doing the identification after the fact. So if you want information on the open source repo, where to find it, how you can customize this, just come and see us at the end of the session. So I'll pass back to Scott to talk about the next steps and close.
Thank you, Patrick. And we'll switch over to the slides. Great. So I just want to talk about, thank you all for coming and talk about a couple next steps. And then I think there were 2 questions in the dory that we'll try to answer quickly before we finish here. But first, again, there's a couple links on there to go and check out DLP and some of the other things you can do with it. Also there are 2 other related sessions that you might find interesting. One is today, right after this session, that I'll be going to as well. I'll be speaking there, actually. It's at the Park Central Hotel. It's right after this. And another one is on Thursday, which is a customer looking at kind of comprehensive protection of PII in GCP. And that's, again, this Thursday at 1:15. And so again, thank you all for coming. There's 2 dory questions I'm going to answer. And I'm going to paraphrase them, so if I get them wrong, then just come find us afterwards. But the first one asked is, can this be used in kind of multi-cloud or hybrid or on-prem environments? The answer is yes. So when you look at our API, there are really 2 modes you can run it in. There's a streaming content mode. And in that mode, the data can really come from virtually anywhere. It could be on a mobile device, and maybe you're streaming it before you save it. It could be on another cloud. It could be on-prem. Now, it is going to be using our cloud to process and inspect or de-identify the data, but that mode does not persist the data. So the data does not have to be in GCP. It does not have to be stored in cloud storage or BigQuery. It's simply streamed in, and the response you get back in that API call is either your findings, if you're doing inspection, or it is your actual masked or transformed payload. And that is on text, tabular data, as well as images. We can mask the images as well. The second question was around keys. I know we showed some examples here where you actually saw the key, so probably don't use those keys. But it was a question around, can you use something like KMS or key management system on those keys? And the answer is yes. So we actually have an integration with KMS. The idea is that you would wrap the key in KMS. So the thing you're providing in the API call or in a pipeline, like in that template, is wrapped. So if someone saw it, somebody got access to it, they can't actually run the key to tokenize data or de-tokenize data. They would have to have actual access to the key. So that gives you another avenue for auditing and access control using KMS. So that is definitely the preferred method. But if you have other systems where you need to stream the key in, we do support it. And I think that was the last one on the Dory question. Okay. Okay, so the performance implications of DLP. So it depends a lot, obviously, on how you're using it. We have built the streaming API to support real-time environments. So again, we have some demos we can show you at our booth if you want to stop by, where we're typing in one box and it's literally showing up pretty much in real time on the other side. So again, it depends a little bit on the complexity of what you're sending in, how big it is, how much it is. But it is going to add a little bit of processing into that pipeline. Now, if you're doing at-rest scanning is another thing that we do support. So imagine you have your data warehouse or your data lake, something sitting in like GCS, and you want to do sample scans or just periodic scans of that data. We also support that mode. That's our second mode, which is, we kind of refer to it as a storage mode. And when you're doing that, again, depending on how big your data is, how you're sampling it, things like that, but you're usually running that in kind of a background periodic job. In the example, I think today with Dataflow, we were using the streaming part of the API and using Dataflow to parallelize everything. And so we were able to process a lot of data in a very short window. And so that's kind of a lot of the power. Because it's not persisting data, because it doesn't have state, you can parallelize the API. And at that point, you're just dealing with number of workers, total quota and things like that. But with that, I think we're just about at time. Thank you again for coming. If you have any questions, come find us at the booth over in the security neighborhood. Thank you.